All right, cool. Well, welcome everyone. Thank you. Please keep me on time. So today we're going to be reviewing the blockchain transparency primer. So let's get started. So the name of the paper is called Enforcing Transparency, Consistency, and Reliability in Digital Advertising Using Blockchain Technology. Next slide. Cool, so intro. All right, so what is the Trifecta? So we're a subgroup, that is the name of our subgroup. It's a subgroup of the AdTech Lab, blockchain working group. And we're releasing a primer. This is the document that we're releasing. And this presentation basically reviews that primer. Fun? Cool, so within the Trifecta, the reason that we're called the Trifecta is because we focus on three key areas. Those are registries, shared ledger, and billing. The most important one definitely being shared ledger. But we provide guidance around the other two. Let's go to the next one. So what are our goals within the Trifecta subgroup? So we want to primarily, we want to educate the public on the usage of blockchain in digital advertising. So we want to just educate, want to put materials out there, making sure that people understand where it makes sense and where it doesn't make sense. And more importantly, we're designing protocols to bring trust to digital advertising using the blockchain. That's the most important goal. Let's keep going. So registries. Cool. So registries are a very common usage of the blockchain. I think there's a few registries. I participated in one called AdTech, which is the Publisher Reputation Registry. But you can think of a blockchain as a programmable DNS. So today we're using DNS for things like apps.txt, and other things that are coming down the pipeline in OpenRTB. But you can think of a blockchain as that, but programmable. And crypto economics is awesome. So what we do in blockchain is our job is we basically exploit incentives and we build these crypto economic systems to do that. So some examples of blockchain registry. So as.txt plus. So imagine where you have one central registry that houses all the relationships for publishers and sellers. So imagine that if you're a publisher, and I'll get into this a little bit more, you can prove your identity on the blockchain. Let's say you have an as.cert. That as.cert is the same identity on the blockchain, and then you can have the central repository of a registry, and then you can have events, you can have triggers, you can have all kinds of programmability in that registry. Publisher reputation, so this is where crypto economics comes in. So if you look at programs like AdChain, where people are incentivized to basically do the hard work of finding fraud. So for example, in mobile, especially mobile in-app, it's really, really hard to find fraud. And so the best way that can currently be done is through human labor. So a human can actually go in there and flag all these fraudulent apps and give them a reputation. Campaign registry, kind of like NIAX, I think MediaOcean, some other companies are doing it. Pretty straightforward, transparency in the transactions. And consent registry, so this is like privacy chain. We want a consensus, a consortium to house all this data to basically, so we can enforce the standards as to how you use consent. So that's the consent registry. So that's it for registries. We just want to give you education, use cases, and that's it. Next one. Cool, so shared ledger. So first, I'm gonna give an overview of OpenRTB today. So first, I'm gonna give some definitions. So I wanna first define transparency. So here we have a depth. So what is transparency then? Well, how much do you know about a given path of a bid request? So for example, you usually only know about the person or company to your left or to your right. So for example, here a DSP has a connection to the agency and has a connection to the exchange. That's the transparency depth, pretty straightforward. Next slide. But then we start getting into transparency height. So what is transparency height? Well, how much do you know about how others are behaving? So for example, as a DSP, how do you know how other DSPs are behaving? How can you have enforceable auction mechanics when you don't really have that transparency? Now, you don't really actually want, there's a lot of, you have to be careful when you're managing all this transparency. But for example, an exchange knows how other DSPs are bidding. So, but DSP does not know how other DSPs are bidding. And so that's what we call transparency height. Next slide. Cool, so what do we want? So if you all attended yesterday's sessions, basically the whole talk, a lot about it was securing the supply chain. Yeah, basically there was a lot of talk about ads.cert and all this, and that's basically what we want, right? Within OpenRTB, within programmatic, within AdTech, we want cryptographic enforcement. We want auction enforcement. I know Google is moving into this area of a unified auction. We can do that without Google, right? We can create systems in which OpenRTB can actually be enforceable with safe auctions, and yeah, no Google. And then we want end-to-end validation. So today, even with ads.cert, right, ads.cert, let's say OpenRTB went live today, a buyer can validate the publisher, but a publisher cannot validate the buyer. There's things coming up such as the supply chain object, seller-side JSON, which is supposed to validate the intermediaries, but there's a lot of exploits there, a lot of holes there. And so we want like something that actually provides auction enforcement and end-to-end validation. So what are some examples? So I'll give you some pretty basic examples here. So malware, bid caching. So here, for example, here is something that we want to be able to prevent, is bid caching. So as a publisher, you can send a bid request to two different paths, to exchange A, exchange B, DSP B, and then get both bids and then serve both bids. And we don't want that, right? Like, you should go out to the market for every single bid, because that's bid caching. Sure, bid caching for technology, for tech purposes makes sense, but like the buyer, right, they bid on the first lot, not the second lot. So that's the type of thing that we want to be able to catch. And for example, how do you catch this? Well, you can get a signal from either this and one of these. So it's one of these plus one of the other two. And so that's how shared ledger basically stops this type of behavior. Next slide. Cool. So that's just an overview of OpenRTB, where we are today, what we want to achieve. And next we'll talk about how, and a little bit how shared ledger fixes that. So yeah, introducing shared ledger. It's basically a messaging layer for OpenRTB and Direct.io. So it's not just for programmatic, this works for just anything. It provides consistency, transparency, enforcement, security, auditability, and reconciliation today. So as you can see here, it's pretty basic. You have all your entities sending data to the shared ledger, but notice how the entities are stacked. And that's how you get the transparency hack. Next. Cool, so here's the fun one. All right, so how does ads.cert and blockchain go together? Well, so this is some work that we're still doing within the OpenRTB working group. But basically, we're making ads.cert compatible with popular blockchains. So today, we're using a specific elliptic curve, but we're gonna switch to the one that Bitcoin and Ethereum uses. And the purpose of this is so that they're interoperable. There's another standard called ED25519, which is faster. We could potentially use this in OpenRTB, but with very poor support for this. So, if you have an ads.cert as a publisher, guess what? You already have a wallet. You already have an identity. You can receive payments on that wallet. You don't even have to know this. You can resolve disputes. You can prove things, right, with your ads.cert. Yeah, blockchains are cakes, right? So this is how you basically scale a blockchain, right? Like blockchain, you're not gonna really write to the blockchain for every single transaction. That's not gonna work. The way that you actually design blockchains, the way that you actually design system is with layers. So for example, a root layer can be like Bitcoin and Ethereum. And then you have your second layers like Lightning, it's a popular one, side chains, which is what we use, and Plasma, which also we use. And then there's third layers. You can actually add a layer on top of that. So that's what OpenRTB is. So imagine you can have the OpenRTB is a transactional layer on top of the secondary layer, which ultimately is pegged to the root chain. And then you can have trickling proofs. So if you're interested in this, definitely check out Lightning or Plasma as to how you can create fraud proofs and all of this from second layer transactions. Yeah. Cool. So so the primer goes through all of this. It'll be out for comment in the coming days, and we give some guidance. So number one, how do we avoid the garbage in, garbage out problem, right? I think maybe some of you have seen this problem. I'm sure people like say this, oh, this is a problem that's like not fixable, but it's not really a problem when you design the system well, right? So why are Ethereum smart contracts not vulnerable to this? Well, because you're dealing with digital goods. Like if you were not dealing with digital goods, like say we want to track this chair or whatever, like it doesn't make sense, right? But or when you're submitting aggregate, that's when it's susceptible to this problem, right? Like in Ethereum, you're not submitting aggregates, you're submitting individual transactions which change the state. And so we want to basically emulate that. We want to not be vulnerable to garbage in, garbage out. And so we emulate smart contract transactions by doing everything at the event level. So every event is basically a transaction. It's not a full transaction, more of a message, but that kind of depends on the implementation. Ideally, it's a two-way signing, but transaction IDs. So so basically we encourage everybody to start exposing OpenRTB 2.5 and up bid request transaction ID. And this is how you trace everything. So this is how you can basically trace the bid request across different exchanges, across different DSPs, and so on. And so we want to encourage people to start exposing that. And we want to provide consistent identity, right? Like today, Pepsi might be like PepsiCo, Pepsi Media, whatever Pepsi brand on different dashboard. We want one Pepsi, right? And we want everybody to be known by one identity, and that's going to be their domain. So you as a publisher, for example, we're doing this today. So as a publisher, you can have a domain, but then you have sites which have their own domain. But as a publisher, you're only going to have one real primary domain, and that's going to be tied to your reputation as well. Next one. Cool. So, what are the advantages of shared ledger besides security, which is big? Well, one thing that you're going to get, which you're not going to get if you try to get, like as a DSP, if you try to implement this, well, this works across DSPs, right? So if you're going to go and try to use a DSP, you're only going to get their data. Whereas a shared ledger works across DSPs, across the exchanges, more importantly, consistent, one implementation, right? So like today, as a TXT, as a cert, if you write the session, all the vendors have to implement it. The buyers, the DSPs, the exchanges, the publishers, everybody. With shared ledger, there's one implementation that only one company or group of companies have to implement, and it's consistent, right? So now as a buyer, you have consistent, so if I'm a buyer, I want to buy an impression through exchange A or exchange B or DSP C or DSP whatever, and have it mean the same thing. I want to pay for an impression that means the same thing across these different supply paths. And so that's what we want to do. And of course, ultimately, that gives us agreeable numbers and efficient billing. Cool. So one last cool thing that I really like, which is one of the things that the blockchain really provides that's different. So introducing receipts. So basically a receipt proves things that happen in the ledger. So a receipt is basically, as an agency, you can prove to your buyers that you're being transparent, that you didn't misbehave, that you follow standards, that it was consistent, the numbers didn't change. It proves transparency, and the receipts provide proof of inclusion, exclusion. So basically, was a signal included or excluded in computation, which is very important. So what were the measurement standards followed? And so all of this, you don't even have to trust us. So we're a shared ledger, right, and we implement it. You don't actually even have to trust us for that. We give you the receipts. We show you the receipts of all the computations that happen. And that's why it's a completely trustless system, and that's why, so that's why we're introducing this concept called receipts. Billing, cool. Slide. So fiat still king. Sits on that iron throne or whatever, With consistent and agreeable numbers comes efficient billing. So now you have one ledger, one set of numbers that all the people go. You don't have all the different numbers. Everybody can just go to one place and have agreeable numbers that follow standard. There's nobody fudging the numbers, and you have the receipts to prove that. And no financial department would ever want to deal with a cryptocurrency like Bitcoin. It fluctuates too much, right? It's a nightmare for financial departments. So we give you guidance around that. So we say blockchain has a few killer features that are not, that don't exist anywhere else. Smart contracts, primarily. Programmable incentives. So like as I mentioned earlier, our job is to exploit incentives as blockchain developers, and cryptocurrencies. So definitely I'm a big believer that self-sovereign payments and freedom are very important. And so that's why I went into the blockchain world. And we recommend that you use stable coins. So if you are going to use a cryptocurrency, number one, we say you don't need to because you have a shared ledger to have the agreeable numbers. But if you are going to use that, you should use a stable coin because at least it's pegged to something stable. Now advanced share ledgers, like in Lucidity we support this, but we don't really use it that much, to be quite honest. We support smart contract based crypto payments. So the concept there is as a metric is computed, the smart contract updates the balances, and then you automatically and atomically pay all your vendors and publishers. And so you have financial enforcement. But yeah, we just give you guidance for that. Conclusion. Cool. Yeah. So I mean, we really think that Share Ledger solves many of the issues plaguing AdTech today. Yeah. Again, we only provide guidance for registries. There's no implementation, none of that, or payments. We just give you guidance. However, for Share Ledger, we are providing technical specifications. These are coming down the pipeline, so that all the inputs are standardized, so that as a company, as a vendor, as an exchange, DSP, and so on, you don't have to integrate different ways. It's a one standard, just like OpenRTB. And then very, I think it's very cool, is that we can get this today. So today, we can deploy the system, and vendors don't have to do very little work, if any. Right, today, if you want to go to OpenRTB, there's a lot of work, and this does not rely or require OpenRTB, and you're still getting the same safety, if not more, definitely more. So the primer document is ready for public comments in coming weeks. So yeah, stay tuned, and yeah, looking forward to hearing the comments. Yeah.
Hi. So in one of your slides, you said that you use layers versus logging every transaction for scalability.
Mm-hmm.
In the slide immediately after, you said you still log every event. Can you just help?
Yeah, absolutely. Yeah, so we log every event at the second layer. So like at the layer that you're talking about. So in OpenRTB would be the third layer, but in Share Ledger it would be the second. So we're logging every single event at the secondary layer, and then we use the root layer to provide safety. So basically in Lightning you can create fraud proofs basically. So even though all the transactions, every single transaction is recorded on a secondary layer, you can create cryptographic proofs to prove that that second layer behaved correctly. And so you then settle that on the root chain. Yeah.
And there's no scalability problems at that secondary layer?
No.
Miguel, you're writing a hash to the root chain, right? You're writing a hash?
Oh yeah, absolutely. So yeah,
all the geeks in the room are writing.
Yeah, we use Merkle tree. So basically, so the second layer, for example, operates on transactions which generate a Merkle tree, and then you come to a consensus. On the root chain, you only have a Merkle root, and then you can use that Merkle root to prove things. So as I mentioned, you can prove inclusion, exclusion. You can prove a lot of other things, and yeah, but it's getting really darky. Yeah. Anything else? Yep.
You made a comment about there's no garbage in, no garbage out because it's digital goods and not something else. Can you just talk a little bit about why digital goods is different and so garbage out? Absolutely.
So it's all based on the Oracle problem. So whenever you have an Oracle submitting things, you're gonna have this problem, right? So basically in digital goods, you have an Oracle that's telling you something about this share or something like that. Whereas with a smart contract, it's about the state transitions. So basically, one action from one party is going to affect this thing. Another action from a different party is going to affect this thing. And so yeah, it's basically when you start talking about like dealing with oracles that are submitting data that is not like verified through multiple parties. That's when you have that problem, basically.
So how do you enforce a consistent identity in that case? Because I'm a Group M, so MediaCom calls Pepsi. Group M calls Pepsi, PepsiCo.
Yeah.
How do you enforce it?
We would call them Pepsi.com. That's it. Yeah, that's it. So everybody would be known by their primary domain. And then you can have mappings. So, but that's up to you if you want to have a mapping between Pepsi.com and Pepsi. But no, from our point of view, from Share Ledger's point of view, you're known as Pepsi.com. Yeah.
On the root chain piece, what sort of informed the decision to go with a permissionless ledger versus a consortium or?
Oh, yeah, absolutely. So number one, security. So open ledgers are way more secure than a private ledger, a consortium ledger. We don't need our root layer to be a consortium layer. We derive privacy from being a secondary layer, and so we only store hashes on the root layer. So we need the protection of the decentralization of the root layer. So otherwise it'd be really vulnerable, and you can roll back those transactions. Number two, we need the tooling in the open blockchain. So like things like Etherscan are very useful tools. Provides a lot of tooling. Yeah, think those are primarily. There's just no reason for us to have to use a private consortium. It doesn't make any sense for us because we deal with privacy on the secondary layer.
Okay.
Thank you.
Thank you for your help.